Hi everyone, it's Miss Costa here, and in this video we're going to go through some of the most likely topics that are going to come up on the paper 2 for Edexcel 2024. Obviously not every single topic is going to come up, but it's my best guess as to what might. Okay, so for the first question we're dealing with an inequality. So this we can solve just like an equation. What would we do if it was an equation? We'd say 22x is 7x plus 9. I'd subtract 7x from both sides, so that's what I'm going to do here as well. Take 7x from both sides, so I'd be left with 15x is greater than or equal to 9, and then the next step would be just to divide both sides by 15. So x is greater than or equal to 9 over 15. It doesn't ask me to simplify, but you can if you want to. So x would be greater than or equal to, if I divide both numerator and denominator by 3, I'd be left with 3 over 5. For the next part, it's saying, show the set of values of x for which minus 4 is less than or equal to x plus 2, which is less than 7. So what I do when you've got a double-sided inequality, you just do the same to like all three parts of the inequality. So I'm going to subtract 2 so that I get x on its own. So I subtract 2 from everywhere. So minus 4 minus 2 is minus 6 is less than or equal to x, which is less than 5. And then I just draw that on my number line. Remember that if the inequality is equal to, it will be a coloured in dot. So that would be if it's one of these signs, and if it's not, then you just leave it blank. So minus 6 is going to be a coloured in dot, and then 5 is going to be a blank dot. And then you just join your two dots together, and then that's your inequality represented on the number line. So in this question, I'm told that Jackie buys a pack of 24 packets of crisps and that it costs £3.65. She then sells all 24 packets of crisps for 40p each, and I need to work out the percentage profit. So I know that the original cost is £3.65, and then I want to work out how much she sells it for. So if I do 24 times by 0.4, that gives me £9.60. So she sells them for £9.60. So the profit she makes would be anything she sells it for minus the cost. So £9.60, take away £3.65, gives me £5.95. So the difference between how much the cost and how much she sold it for is £5.95. I write that over the original cost, and then I times it by 100 to work out her profit. So £5.95 divided by £3.65 times by 100 gives me 163.0136986. I need to write this answer correct to one decimal place. So I look over here. This is not greater than 5, so I just leave that as 163.0%. It's important because it says to one decimal place. You want to have one decimal place after your answer, even though it's a 0. So her percentage profit is 163%. To double check, what we could do is 3.65 times by 1.63. And does that get you to £5.95? Yes, so you know that you're correct. Okay, so in this question, I'm told that a group of men and women attended a concert. There's a lot of information here, so I might just start by doing a two-way table. So just to divide up my information and just so that I can keep track of what I'm doing. So men, women, and then each of them either sit in the balcony or in the stalls. And then I'm going to have my totals column as well. So total over here, and total over here. So let's see what I can fill in. So I know that the ratio of the men to women is 3 to 5, and I know that each person had a seat either in the balcony or in the stalls. 3/5 of the women had seats in the stalls, and 252 women had seats in the balcony. So 252 women had seats in the balcony. Now, if 3/5 had seats in the stalls, that must mean that 2/5 had seats in the balcony. So 2/5 is equal to 252, and I could work out what 1/5 is. So 252 divided by 5. No, 252 divided by 2, sorry, is 126. So 1/5 is 126, and therefore to work out 3/5, I times that by 3. So 378 women must have had seats in the stalls. So I can add my totals for my women together. So 378 plus 252 gives me 630. So I know that there are 630 women. Now, if I know how many women there are, I could figure out how many men there are because I know that's in the ratio 3 to 5. So men to women is 3 parts to 5 parts. So 630 represents 5 parts. So 630 divided by 5 is 126. So 1 part is equal to 126, and I need to multiply that by 3 to figure out how many men there are. So I times that by 3, and that gives me 378 men in total. What else am I asked? There are exactly 2,500 seats in the hall. Were there more than 55% of the seats occupied? Okay, so what I need to work out is how many of the seats were occupied. I know that 378 plus 630 gets me to, oh, what happened there? 1,008. So I know that 1,008 of the seats were occupied. And now I just need to turn this into a percentage. So 1,008 over 2,500 times by 100 tells me that 40.32% of the seats were occupied. So I'd say no. But remember, whenever you're saying questions like this, if you just answered yes or no, you get nothing. You need to show you're working and also give like reasoning. So no, 55% were not occupied because only 40% were. Okay, so here I'm being asked to find the lowest common multiple of two numbers. Now I could start by just doing the times tables of both of the numbers and then find the first number that is common to both of them, or I could just do a factor tree. So I'm going to do the factor tree method just because I think it's a bit quicker. So 34, two numbers that multiply to make it are 2 and 17. Both of those are prime numbers, so I circle it and I found all of the prime factors. 45 is 5 times 9, 5 is a prime number, and then 9 is made up of 3 times by 3. So I know that they are the prime factors. If I did a Venn diagram, 34 and 45, I'd realise that none of the numbers overlap. So for 34, that's 2 and 17. Over here, we've got 5, 3 and 3. So the lowest common multiple is going to be all of the numbers in the Venn diagram multiplied together. In this case, it's going to be 34 times by 45 because there's no numbers in the intersection. So that would be 1,530. You could also have found that just by doing 34 plus 34 plus 34 in a calculator and the first number that comes up. But I think the factor tree is a little bit quicker. Then over here, I'm given two numbers in their prime factor form, and I'm asked to write down the highest common factor. So once again, what I could do is a Venn diagram. I've got A and B, and you can write it out like this. So A is 2 times 2 times 2 times 2 times by 3 times 3 times by 5, and B is 2 times 2 times 3 times 3 times 3 times 5 times 5. So then I can like just cross out anything in common. So I've got 2 in common, another 2, and that's it. Then I've got 3 in common, and then another 3, and then a 5. So the highest common factor is going to be all of the numbers multiplied inside the intersection, which is 2 times 2 times 3 times 3 times 5, which handily, you've got a calculator. So 2 times 2 times 3 times 3 times 5 is 180. So here I've got a bearings question. So I'm told that the bearing of a ship from the port is 126 degrees. So let's try and draw a diagram. With bearings, you're always going to get like parallel lines because you always start your bearings from due north. So the bearing of a ship from the port is 126 degrees. And if you just think about your angles in general, so you know that's 90, 180, 270, you know 126 is going to be roughly like that. So we can draw a bearing that looks roughly like that. I know that this angle is 126 and this is the port. So this is where the ship must be. So the bearing of the ship from the port is 126 degrees, and I need to find the bearing of the port from the ship. So we always start from where it says from. So we're going to start from the ship, and remember every bearing starts from due north, just so that we can have consistency. And you always have to start from due north and go round clockwise. So I'm going to have to go round this way until you reach the line, and that is going to be the bearing of the port from the ship. So in order to do this, I use my knowledge of angles on parallel lines. So these two lines, due north, are parallel lines. So therefore this angle and 126 must sum to 180, because co-interior angles sum to 180. So 180 take away 126 is going to give me 54 degrees. Obviously use a calculator if you need to. And then I know that angles on a point must sum to 360. So I just do 360, take away 54, and that leaves me with 306. So the bearing of the port from the ship is 306 degrees. The key things about bearings: you start from due north, you go clockwise until you reach the line, and your bearing must be a 3-digit number. So if I got 54 degrees, I would write that as 054. Okay, so here I've been given a diagram of a rectangle and a triangle, and I'm told that the area of the triangle is 13.5 centimeters greater than the area of the rectangle. And then I need to find the perimeter of the triangle. So how do you work out? Let's start with the rectangle. The area of a rectangle is always base times height. So I'm going to do 6 times by 3x plus 2. And I don't need to write the times, because when I'm multiplying two terms or more, I can put them in a bracket. So I know that's the perimeter, the area of the rectangle. And then the area of a triangle, how do you work out the area of a triangle? It's base times height divided by 2, a commonly forgotten thing, especially under exam pressure. So that would be 5x times 7 is 35x divided by 2. And I know that the area of the triangle is 13.5 centimeters squared greater than the area of the rectangle. So therefore I'm going to add 13.5, because whatever this area is plus 13.5 is equal to this area. That's why I formed an equation for myself. So now I can just expand everything. So that would be 18x plus 12 must be equal to 17.5x plus 13.5. And I have a double-sided equation, and now I can just move things from one side to the other until I solve it to find x. So I could take away 17.5x. So I know that 0.5x plus 12 is 13.5. And then I subtract 12 from both sides. So 0.5x must be equal to 1.5. So I know that x divided by 2, like 0.5 is equal to a half, must be equal to 1.5. Therefore, if I times both sides by 2, I know that x is equal to 3. Now that I know what x is, I can substitute that in to figure out what the perimeter of the triangle must be. So if x is 3, then 5x must be 15. 5 times 3 is 15. So I've got a triangle, and I need to work out its perimeter. It's a right angle triangle. So I've got 7, 15, and I can use Pythagoras to figure out its hypotenuse. So Pythagoras is a squared plus b squared equals c squared. So that must mean that 7 squared plus 15 squared must equal c squared. So I can type that into a calculator. 7 squared plus 15 squared equals 274. And then the final part is to just square root in order to get your value of c. So square root of 274 is c, so therefore c is 16.5529 and so forth. Now I need the perimeter. So the perimeter is just the distance around the outside of the shape. Imagine you're just a guard walking around the perimeter. So I'm going to do 7 plus 15 plus 16.55. So I add all those values together, plus 7 plus 15, and I'm left with 38.5529. It says give your answer to 3 significant figures. So I'm going to round this digit, so that would be 38.6. I circle the digit, look next door. If it's more than 5, then I'm going to round it up. So x is 38.6. Oh, well, that's supposed to say the perimeter. Perimeter equals 38.6. So here I've got an error interval, but it's a slightly different one that people frequently just overlook, because truncation is kind of like this weird thing that you're like, why do I do this if I know how to round? So when I truncate, let's just give a random example, 6.47983. When you truncate, you literally chop off where it says, so to one decimal place, if you truncated it, you literally just would write that as 6.4. You don't consider rounding at all. If it was to 2 decimal places, it would be 6.47. And if it was to 3 decimal places, it would be 6.479. So you literally just chop off anything after your decimal and you just leave it as it is. You don't worry about rounding. So that's what truncation means. So I know that crisps are packed into 30-gram bags, okay, truncated to the nearest gram. So what that must mean is that it's rounded to the nearest decimal place. So the lowest possible value it could be, if I think about my decimal places, it could be 30.000986, blah, 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 blah. So the lowest possible value it could be is 30, because if I truncated it, the first digit could be 0, the second digit could be 9. It doesn't matter because I'm truncating. So the lowest possible value would be 30. If it was 29.99 whatever, then to the nearest gram, I would have just truncated it to 29. So that's why 30. And then, because it's been truncated to 30, I know that it must be 30 point something. The highest possible value it could be is 30.9 recurring. But because the error interval says less than, I'm going to say it would be 30 to 31, because it could technically be 30.9 recurring. So anything under 31 is what it could be. And that's how I do an error interval with truncation. Okay, so here I've got a cumulative frequency diagram, and I've got a frequency table. I'm told that the table shows information about the ages of 80 people going on a mountaineering expedition. First part, I need to complete the table. So I know that there are 80 people in total. This is just a frequency table. So the first thing I have to do is add all my frequencies together. So 38 plus 22 plus 5 plus 3 gives me 68. So therefore, I know that 80 takes 68, leaves me with 12 people. So the missing interval must be 12. Now my frequency adds up to 80 and it's complete. I then need to draw the cumulative frequency graph for this information. So what I'm going to do, and what I'd advise you do if you don't have this like table extended in the exam, is just do an extra little table for cumulative frequency. So the first part is 38. And when I do cumulative frequency, you literally just add on everything beforehand and you keep on running like a running total. So 38 plus 22 is going to give me my next value. So over here is 60, 60 plus 12 is 72, 72 plus 5 is 77, and my final value is 80. The way you know you've done it right is you know the total is 80, so your final value must also be the same as the total. So let's draw the graph. When I'm drawing a cumulative frequency graph, you always plot against the last value. So my first thing is going to be 30 and 38, so over here, then 40 and 60, then 50 and 72, then 60 and 77, so 5, 6, 7, and then 70 and 80. So this is a bit of a strange cumulative frequency, but hey, just go with it. So we start from 20 and then we just join our dots together. Normally a cumulative frequency graph would look more like that, but you just plot what you're given, and actually that doesn't look that great, so let's just try it again. So there we go, that's more like it. Okay, now use the graph to find an estimate for the number of people aged over 42. So what I do when I'm estimating using cumulative frequency, I go along the axes they've told me. So people aged over 42, so 42 would be here. You draw that with a ruler, but I don't have one. And then you go up to the graph, and that tells you that's 61, 2. Okay, so from 62, that is your cumulative frequency. I want to know the people aged over 42. So it's going to be everything over 42. So from 62 to 80, 80 takes 62, gives me 18. So therefore, there must be roughly 18 people over the age of 42. Okay, next. The youngest person on the expedition is 23. The oldest is 62. Use the information from the cumulative frequency graph to show the distribution of ages. So for a box plot, you always plot it like this, where this is your least value, this is your greatest value. The box ends at the lower quartile and the upper quartile, and this represents your median. So from my cumulative frequency graph, I'm going to need to get the lower quartile, the median, and the upper quartile in order to complete this. So let's quickly go back. The lower quartile is going to be a quarter of your data. So a quarter of 80 is 20. So I go across 20 down my graph to, that would be 26. So the lower quartile is 26. The median is half of your data. So that would be 40. And I go along 40. And then, is that 2? I think that's 1. And then down to 31. So my median is 31. And the upper quartile is 3/4 of your data. So 3/4 of 80 is 60. So I go along and then down to 40. So my upper quartile is 40. I then have all the values I need to draw my box plot. So my least value is 20. So I need to actually design an axis. So I know I might start at 20. Let's see if that's enough. 30, 40, 50, 60, and 70. So they've given us a nice one. So 23 would be 1, 2, 3. That's my least value. My greatest value is 62. So I draw a line here. My lower quartile is 26. So 25, 26. My upper quartile is 40. And then the median is 31. So I draw the lines, and then maybe I made it a little bit too big. So I'm just going to chop that off. Imagine that it's just got those bits chopped off. Oh, it chopped off the whole thing. Okay, well, yeah. So that's how I draw my box plot. Now, what does the box plot tell you about the distribution of data? Well, it tells me that 75% of the adults are under 40. So the cool thing about the upper quartile and the lower quartile, this data here represents the middle 50% of the data. This is the bottom quarter, bottom 25%, and this is the top 25%. So basically the spread of data, there's a lot more people, a lot more younger people on the expedition. So 75% of the adults are under 40. And that's all we need to say because we're not comparing it. Okay, so in this question, I'm told that Jessica invests £20,000 in an account paying compound interest for 3 years. In the first year, the interest rate is X%. So I don't know what the interest rate is. But at the end of the first year, her investment has a value of 21,100. So how do you work out compound interest? You have your original value times by your multiplier, and then to the power of the number of years. But we know that it's just 1 year that we're working out. So what I'm going to do is write £20,000, my original value, times by my multiplier. I don't know what that is. For now, I'm just going to say Y. And when we do multipliers, you always do it. So I know it's increasing. So you do 100% plus your interest rate. So times by Y% must equal 21,100. So to figure out what my multiplier is, I'm going to do 21,100 divided by 20,000. And that gives me 21,100 divided by 20,000 is 1.055. 1.055. So I know my multiplier is 1.055. So if I think to myself, 100% plus something divided by 100 gives me 1.055. The interest rate is essentially this bit over here. So the interest rate, X percent, is 5.5%. Now, if I know what the interest rate for the first year is, I can use that to figure out what the interest rate for the next 2 years would be. So the interest rate for the second and third year is X divided by 3. So 5.5 divided by 3 is probably going to be a nasty number. So when I do my compound interest, I can just write it as a fraction. So I'm going to say 21,100 times by, or I think I have to add it actually. So 5.5 divided by 3 is 11 over 6, which is 1.83 recurring. So my new interest rate, X over 3, is 1.83 recurring. So if I think about my multiplier, 100% plus 1.83 recurring, if I add that together and then I divide by 100, that gives me 1.0183 recurring. So if you're a bit confused about multipliers, then start with 100%, add on your interest rate and divide by 100. So I'm going to do 21,100 times by 1.0183 recurring to the power of 2, because it's for 2 years, for the second and the third year. So 21,100 times by answer squared is £21,880, 75861. So to round it in money, that would be £21,880.76. Okay, so simplifying. So question 10, key point, anything to the power of 0 is 1. So I don't need to worry about simplifying anything. I just say that must be equal to 1. Next, I've got this nice algebraic bracket. So what I can do is just expand the denominator. Remember that anything squared means multiplied by itself. So if you see a bracket is squared, it means the bracket times by itself. And then with an algebraic fraction, as long as the numerator and the denominator are products, so they're just being multiplied, they're not being added, then you can divide anything on the top by the bottom, because like anything divided by itself is 1, so it cancels out. So this bracket and this bracket I can cancel out because anything divided by itself is 1. So I'd be left with 13 over x minus 3. Next, I've got this bracket here. Now, this is just something that people always just forget. Every part of that term is being cubed. So it would be 4 cubed times by x to the power 4 cubed times by y squared cubed. Okay, so if this is something that trips you up, then literally just write out the bracket for 3 times. It's cubed, so just write it out like this 3 times, and then that should remind you, or it should be the signal that you're like, oh yeah, 4 needs to be cubed as well. So 4 cubed is 64. X to the power 4 cubed, when you've got brackets, you just multiply the indices. But again, if you've written it out like that, then you know that you'd add them. Repeated addition is the same as multiplication. So x to the power of 4 cubed is going to be x to the power of 12. And then we do the same. 2 times 3 is 6. So that would be y to the power of 6. Okay, so in this question, I'm told that Jamie is at an ice cream factory. It's pretty exciting. There are 3 types of ice cream cones, 24 ice cream flavours and 13 toppings to choose from. Jamie is going to choose 1 ice cream cone. So if we think about it like this, we've got an ice cream cone. Maybe it's got a nice chocolate like surrounding. 2 scoops of ice cream. So he's going to have 2 scoops of ice cream and 1 topping. So I don't know, that could be like sprinkles or chocolate or whatever. Anyway, we've got our chocolate. I mean, we've got our ice cream there, and the combinations are, I could have 3 cones. He's going to have 2 scoops of ice cream, and there are 24 different ice cream flavours. So his first scoop could be any of those 24, and his second scoop could be any of those 24, because you could have double chocolate or double strawberry or double pineapple or whatever. So he's got 2 options there, and then he's got 13 toppings that he could choose from. So what I do, instead of combining, so instead of saying, okay, I could have cone 1, 2 or 3, and I could combine that with 1, 2, 3, 4, 24 flavors, and then each of those 24 flavors I could combine with 1, 2, 3, 24 flavors. Instead of adding them and writing them out systematically, we know that we can multiply, because repeated addition is the same as multiplication. So whatever your options are, we just multiply. So this is going to be quite a lot of possible combinations that he can make. But then again, if it's an ice cream factory, that is what you'd expect. So we do 3 times by 24 times by 24 times by 13, which gives you 22,464. So he's got a lot of choice. Okay, so here I've been given some algebraic fractions and asked to solve them. Now the first thing, just like any bog standard fractions, in order to add or subtract any fraction, they must have the same denominator. So that's the first thing that I'm going to try and do when I look at algebraic fractions. So over here I've got 5x minus 3 over 4 take 3x plus 2 over 5. And I don't need to worry about this side yet, because I'm just turning my fractions into equivalent fractions, so I'm not changing their value. So the lowest common denominator of 4 and 5 is 20. So that is what I'm ideally going to turn these fractions into, so that I can then subtract them. So if I multiplied 4 by to get to 20, I've times by 5. So I'm going to need to multiply this numerator by 5. And what if I multiplied 5 by to get to 20? I've multiplied by 4. So I need to multiply this numerator by 4 in order to keep the fractions in the same proportion. So now they're both over 20, I could first of all just expand the bracket to make my life easier. So I've got 25x take 15 minus 4 times 3x is 12x, 4 times 2 is 8. Okay, so all of this over 20. So let's see if I can simplify it. Now, this is where a lot of people get caught out, because you were subtracting. So you've got 25x take 15, and then you're subtracting. So what you can do is you can imagine there's a negative 1 there, because you're subtracting 8, so therefore it's going to be minus 8, but some people forget that and they add 8. So because you're subtracting the whole terms, you have to subtract each part. So sometimes it helps to put the minus 1 there, and then you know minus 1 times 12x is minus 12x, and minus 1 times 8 would be minus 8. So you can just use that trick to help you if this part here, when you're subtracting, is a little bit confusing. Then you've got 25x take away 12x, so that would be 13x, and minus 15 minus 8 is going to be minus 23. Okay, so what we've done is we've just simplified this side into one fraction. So now we can write our whole thing out.
1 is a fraction is 1 over 1.
Okay, that was a bit scary. So 13x minus 23 over 20 must be equal to, let's uncover this side, 2 minus x over 10. So now you've just got two fractions, and we just want to solve it, solve for x. So what we could do is we could start by multiplying both sides by 20. So 13x minus 23 is going to be, and when you're multiplying fractions, the reason only the numerator gets multiplied is because if you, let's just say we had x over 5 times by 20, when I'm multiplying, you can think of it as a fraction, so that would become 20x over 5 because the denominator is just going to be 1. That's why only the numerator gets affected. So that'd be 20, 2 minus x over 10, and then you could, well, there's a few things you could do. Yeah, let's just do that. You could multiply both sides by 10, or you could see 20 divided by 10 is going to leave me with 2. But if you're not confident with that, just multiply both sides, just get a bigger number, but it's a calculator paper, so it's fine. So 20 divided by 10 is 2, so I'd be left with that. And then let's keep on simplifying. So 13x minus 23 is going to be 4 minus 2x. So now I just have a nice double-sided equation. I just want to rearrange things to find x. So I can add 2x to both sides. So I'd be left with 15x minus 23 equals 4. and then I just add 23 to both sides. So 15x equals 4 plus 23 is 27. And then the last step would be to divide both sides by 15. And x is 27 over 15. Because it's a calculator paper, you could plug that in, but it's fine to just leave it in its fraction form, because anything that is the right answer or equivalent will be fine. So 9 over 5 is 1.8, unless of course it says give your answer as a decimal. So read the question. But yeah, that's how we do that. The key thing is, remember that to add or subtract, they need the same denominator. Be careful when subtracting that if you're subtracting, you have to subtract each term individually, and then it's just a matter of rearranging until you find the value of x. Okay, so I'm told that the population of Europe is 7.465 times 10 to the power of 8 million, and for England it's 6.794 times 10 to the power of 7 million. I need to work out what percentage of the population of Europe live in England. So essentially, I need to write the population of England over the population of Europe, and then times by 100. Just like if I said I got 45 marks out of 60, I'd write that as 45 over 60 times 100 to work out the percentage. So I'm going to type into my calculator 6.794 times 10 to the power of 7 over 7.465 times 10 to the power of 8, and then times it by 100. So let's see what that gives me. You can use your fraction button. So 6.794 times 10 to the power of 7 over 7.465 times 10 to the power of 8 times by 100 gives me 9.101138647. So that's actually quite a large percentage, like nearly 10% of the population of Europe lives in England. Okay, wow. So give your answer to two significant figures. The second significant figure is that, so that would be 9.1%. Okay, so I've been given 3 inequalities and I've been asked to shade the region that satisfies all of them. So the nice and easy one is this one here. If you ever have a y equals or an x equals, you know they're just going to be straight lines, horizontal or vertical. The y equals line is going to be horizontal, x equals will be vertical, but let's see why. So let's just draw the line y equals 3. That would be where the line crosses the y-axis at 3, because at every single point, the y coordinate is going to be 3. So that coordinate here is 1, 3, 2, 3, 3, 3, so forth. That's why it's called the line y equals 3, because every y coordinate is 3. And just a key thing to remember, if you have a less than or equal to or greater than or equal to, it's going to be a solid line on your grid. If it's less than or greater than, it's going to be a dotted line, just to represent that the inequality is not satisfied by the actual line. It can't be on the actual line. So that's my first line. Then I've got x plus y is greater than 3. So I could just rearrange that to say y must be greater than 3 minus x. And there's a number of ways you can do this. You could do a table of values, and that's absolutely fine. Or you could just pick a few points to speed up the process. So I know that y is 3 minus x. So if I said that x is 3, 3 minus 3 is 0. So I know that's going to be a point here. If I said that x is 1, y is 3 take away 1, which is 2. If I said that x is minus 1, 3 minus minus 1 is 4. So that's going to be my coordinate. And if I said x is minus 3, 3 minus minus 3 is 6. So I just picked some random coordinates. But if you feel more comfortable, you can do a table of values, or you can just read it off the line. I'm just going to do another one. So let's say x is 5, 3 minus 5 is minus 2. Then you join, okay, and this line is a dotted line. So you join your line together with a ruler, but you just do a dotted line like that. Okay, so that is going to be the line y is greater than 3 minus x. Now I've just drawn them. I haven't said anything about them yet, but we'll do that at the end. And the final line is y is greater than or equal to 2x minus 2. So imagine it's the line y equals 2x minus 2. The quickest way is to just say, okay, what's the value of y when x is 0? So when x is 0, y is 0 minus 2. I mean, you know that anyway, because the y-intercept is -2. Let's do the same for when y is 0. So when y is 0, 2x must be equal to 2, so x must be 1. So when y is 0, x is 1. And then what we can do is just pick another coordinate, so let's say 3. So y must be equal to 6 minus 2, which is 4, so that would be the coordinate 3, 4. If this is confusing, this is just like the quick way to do this. Just do a table of values like this and pick a bunch of coordinates, but this is just a slightly quicker way. And then I've got 3 values. I could join them up, but let's just do another one. So if x is 2, y is 4 minus 2, which is 2. So you've got your line, and it's a solid line, so we join it up. Oh, that's not a very straight line. So we join it up as straight as we can. Now, this is where I want to think about what the inequalities mean. So for this line, y is greater than the line 2x minus 2. So all of the y coordinates must be above. Okay, so everything that satisfies this inequality is above the line. Then for this line, y is less than or equal to 3. The y value has to be less than or equal to 3. So it's everything that is below this line. And then for this line here, y is greater than 3 minus x. So the y values have to be above that line. So therefore, everything that intersects would be in this region here. And you label that R. To double check, what you could do is you could pick a point. So like we could pick this point here, let's say 1, 3. So 1, 3, when x is 1, y is 3, and let's see if that works. Does that satisfy the inequality y is less than or equal to 3? Yes. 1 plus 3 is greater than 3. Yep, that works. 3 is greater than or equal to 2, take away 2. Yes, 3 is greater than 0. So it satisfies all of the inequalities, and that's how you can double check. Okay, so here's a slightly complicated looking question. And there is a complicated way to go about it, but there is also a slightly simpler way. So you've got 3 ratios, x, z, and y, or 3 variables, and we need to write them in the ratio x to y to z in order to figure out what x plus y and y plus z must be. So let's have a look at seeing if I can simplify them, because I know what 3x to 7z is, but I ideally want to get to just x, the ratio x to z. So I'm just going to go through the simple way. If you want to know how this works, just leave a comment and I'll explain the full video. But what we want to do is first, I'm going to divide my x part by 3. So if 3x is 9, that must mean x is 3. Similarly, if 7z is 35, that must mean that 1z is 7. Nope, 5. 35 divided by 7 is 5. So the ratio x to z is 3 to 5. And then I do exactly the same with my next ratio. So 4y to 11z equals 16 to 22. I want to get it in the form just y to z. So what I want to do is find out what one part of y is. If 4y is equal to 16, then 1y is going to be 4. And similarly, if 11z is 22, 1z is going to be 2. So the ratio y to z is 4 to 2. Now what I want to do is write them as a 3-part ratio. So x to y to z. So I know that my ratio of x to z is 3 to 5. So I fill this in. And then my ratio of y to z is 4 to 2. And I can see that I have a common variable. So z is common to both of these ratios. And I want to get it so that it's the lowest common multiple of z so I can compare them. So if I multiply this by 2 and I multiply this by 5, I end up with 10. So let's start by doing 3 times 2 is 6. 5 times 2 is 10. And then this part, for y, I'm going to have to multiply it by 5. So 4 times 5 is 20. So I know that the ratio x to y to z is 6 to 20 to 10. And I need to work out the ratio x plus y. So x plus y is 26 and y plus z, 20 plus 10 is 30. It doesn't say write it in its simplest form, but let's do that anyway. So divided by 2 is 13 to 15. And that's as far as I can simplify it. So quite a tricky question if you don't know the little trick. There is a longer way that you can do it by equating everything, but if you want to know the reason, then let me know. Okay, so I've been told that AB is a line segment, which just means like part of a line on a coordinate grid. And it always helps when you've got coordinate questions to just draw yourself the axes. So you know 0 is here, these are all the positive x's, positive y's, and so forth. So point A has coordinates minus 8, 7. So roughly minus 8, or if I said that's 10, if I just do a 10 by 10 grid, then it can just help me visualize. So minus 8, 7 would be, oh, what happened there? Please don't do that. So minus 8, 7 would be roughly over here. So I can say that's point A with coordinates minus 8, 7. And then point B has coordinates 6, 3. So my x coordinate would be roughly there. Negative 3 is over here. So that would be my point B, 6, negative 3. And I need to figure out the length of this line segment. So it's a length. So I'm going to be using some geometry, and hopefully you recognize that you might use Pythagoras, but if not, then let's have a look at what's going on. So if I were to say, okay, I know what the x values are and I know what the y values are. So I know that the distance from A to B vertically, I start from 7 and I end up at minus 3. So I go from 7 to 0, so that's a distance of 7, and then down to minus 3, so that's a distance of 3. With coordinate grids, obviously we have negative distances, negative values, but as a length, it doesn't really matter. It just means the total distance is 10 centimeters, 10 meters. So the total y distance, if I redrew this triangle just as a normal triangle, and it would be a right angle triangle because that's how you work out your gradient. You work out your vertical and your horizontal. So that would be a distance of 10. And then let's look at the x distance. So I start at negative 8 and I end up at 6. So I go from negative 8 to 0 is a distance of 8. And from 0 to 6 is a distance of 6. And 8 plus 6 is 14. So now I've managed to form a right angled triangle, and I know the lengths of 2 of the sides, and I need to figure out the length of the final side. So all I'm going to do is use Pythagoras in order to figure out what, and actually I could call that AB squared, what the length of AB is. So 10 squared plus 14 squared equals AB squared. So 10 squared plus 14 squared is 296. So 296 is equal to AB squared. So to figure out what AB is, I need to square root it. Therefore, AB must be, square root of answer is 17.20465. And it says give your answer to 1 decimal place. So the length of AB is going to be 17.2. Okay, so here I've been given 2 triangles, ABC and BCD, and some values of the angles and some values of some lengths. And I need to find the length of CD. So, as it stands, I don't have enough information to just use triangle BCD. So that means I'm likely going to have to use triangle ABC to figure out some things, most likely this side over here. So let's have a look at what I've been given. I've been given an angle here, an angle there. And because I've been given 2 angles, what I can do, just to start me off, is just figure out what the missing angle over here must be. Because angles in a triangle sum to 180. So 180, take away 32, take away 28, gives me 120 degrees. So I know that this angle over here is 120 degrees. Now I've been given, I know 3 angles and I know a side, and I'm trying to work out BC. So I'm trying to work out another side. So the best thing to use would be the sine rule, where A over sine A is equal to B over sine B. Is also equal to C over sine C, but you don't need to use all 3. It just means that they're in the same ratio. So let's start by labeling it. I could label this as big A, this is little a. Remember, the big letter represents the angle and the little letter represents the side. So that would be A and A. And then I'm trying to figure out, this side here. So this side here, so its opposite angle would be over here. And having just told you what to do, I've just done it wrong. But there we go. So now I can use that to substitute into the sine rule. So A, 25.2 over sine A, so 120, must be equal to BC over sine 32. So all I do, I've got my equivalent fractions. I need to figure out what BC is. So what I can do is just multiply both sides by sine 32. And that will tell me what the length of BC is. So 25.2 over sine 120. Remember to close your bracket when you're typing in the angle, equals times by sine 32 is 15.4198311. Okay, so now I know the length of that side. Okay, so I know the length of this side, 15.41. I know the length of this side, so I have two sides and one angle, and I'm trying to work out a third side. So if you know, if three sides are involved, then you're going to be using the cosine rule. And let's just recap as to what it is. So the cosine rule is a squared equals b squared plus c squared minus, my brain's just stopped working, minus 2bc cos A. Okay, it's also on your formula sheet, so you don't need to worry about memorizing this. Remember, the little letters represent the sides and the big letter represents the angle. And all that matters is that the side that you're trying to find is opposite the angle that has been given. So this is the side I'm trying to find. This is the angle that has been given. So that's all good. And I know the values of the other two sides. So a squared, I can rename that to BCD squared, just so it's clear what I'm doing, is b squared. And it doesn't matter which side's A, which side's B and C, because you're using the same things for them. So let's just say 19.2 squared plus 15.41, and I'm going to save that as an answer. Squared, take away 2 times 15.41 times by 19.2 times by cos 41. So let's simplify that. So answer squared plus 19.2 squared gives me 606.4111913. I just like to be accurate. And then we can do everything in the bracket. So 2 times by 15.41, and I've written it all out, so I'm just going to write it in again. 198311 times by 19.2 times by cos 41 gives me 446.8797795. So I'm going to just do that subtraction. 606.4111913 take away answer gives me, so I know that CD squared must be 159.5314118. So CD is the square root of this. So CD is the square root of answer, which is 12.63057, and it says to 2 decimal places. So CD equals 12.63. Okay, so here I've been given a cuboid, and so I know that I'm going to be using 3D trigonometry, 3D Pythagoras, and don't be scared by that. All it is I'm going to be using multiple versions of Pythagoras and trigonometry, so do it bit by bit, step by step to get to the next point. So let's start with what I know. I know that DC has a length of 8 centimeters. I'm then told that the ratio of DE to DC is 3 to 2. So if DC is 8, then what have I done to get from 2 to 8? I've times by 4. So this I'm going to have to times by 4 as well. So therefore DE must be 12 centimetres. And that means that all of these sides as well are going to be 12 centimetres. Similarly, all of these sides are going to be 8 centimetres, just in case I need that for later. I'm told the angle ACB is 37. Okay, so then I can form a triangle over here. ACB is 37. So this angle here is 37 degrees. And then what I can do, when you form a triangle on a 3D trigonometry kind of question, always just draw out the 2D version of it. So over here is going to be the right angle because that's where the two corners meet. So you've got this triangle here, where I know that this length is going to be 8 centimetres. I don't know this length, but I know that this triangle here is, this angle rather, is 37 degrees. So I need to then find the size of the angle between CF and the plane ABCD. The plane just means like the flat bit. So CF is this line here, and the plane ABCD. Okay, so then I can draw this triangle here and form a right angle there. So if you visualize what you could do, you've got your right angle triangle here. It's this triangle here. It's a 3D triangle. You can kind of visualize it. It's a little bit hard trying to visualize them. And I know that I need to work out this angle here. So is there anything that is common to the triangle that I've just drawn and this triangle here? Well, they both have AC as one of their lines. So what I know I could do is figure out what AC must be using my first triangle. So let's just write out SOHCAHTOA because that's always just a great way to start the day. It avoids so many silly mistakes that happen just due to rushing. So I've got my angle here. Therefore, this is going to be the hypotenuse, this is the adjacent, and this would be the opposite. Now I want to find the hypotenuse and I've been given the opposite. So O and H. So now I'm going to use sine. So sine theta, so sine 37 is equal to the opposite 8 over the hypotenuse. So the now there's a little trick. We can just switch the subjects, or you can do it properly where you say H sine 37 equals 8 and then divide it. I'm just going to switch them just for speed of time. So 8 over sine 37. So I know that AC is going to be 8 over sine 37, which is 13.2931213. So I know that this length here is 13.29. What else do I know? Well, I know that this side here is 12, and therefore I've been given, I know two sides and I need to figure out the angle. So once again, I'm going to use SOHCAHTOA. Let's label the triangle. What have I been given? This is the given angle, so this is going to be the adjacent. This is going to be opposite. So I'm using opposite and adjacent, OA. So tan theta, the angle I'm trying to work out, is going to be the opposite, 12 over the adjacent, 13.29. And I'm just going to save that as an answer. So therefore the angle is going to be the inverse, so shift, tan, and then your fraction, 12 over 13.299. So I'm going to press shift, tan, and then 12 over answer gives me 42.0732, and to one decimal place would be 42.0. Remember, even if it's a 0, if it says to one decimal place, make sure you write one decimal place, just in case, because sometimes that could cost you a mark. Also, I'm very tired, so I rounded that wrong. Obviously, to one decimal place, that would round to 42.1. Okay, so in this question, I am told that the equation, the cubic equation, has a solution between x is 0 and x is 1. So all that means is that the cubic graph must be crossing the axes between x is 0 and x is 1. And the way to prove that is, well, over here, x is 0, sorry, y is 0. and anything above that, y is going to be positive. Anything below that, y is going to be negative. So if you can prove that between these two values, when x is 0 and x is 1, the y changes from a positive to a negative, then you've proved that there must be a solution between there. So what we do is we substitute the values in. So first of all, we'll put 0 cubed minus 3 times 0 plus 1 equals, and then 0 cubed is 0, 3 times 0 is 0, so that equals 1. So what we're hoping for is that the next part is a negative. So 1 cubed, take away 3 times 1 plus 1 equals, well, 1 cubed is 1. 1 take away 3 is minus 2. Minus 2 plus 1 is negative 1. So I know that the y values are going to be negative 1 and 1. So therefore, to show that there is a solution, you say there is a change in sign from 1 to negative 1, showing there must be a solution. Okay, for the next part, it's just a simple rearranging. Now, you need to show that the equation x cubed minus 3x plus 1 can be rearranged to give the equation they want. So let's have a go. So x cubed minus 3x, I'm just going to subtract 1 from the get-go, is minus 1. Don't panic if you see a negative, because there's a trick we can use at the very end. Then I know that they want to have an x squared, so I'm going to need to factorize that to get x out. So x squared minus 3 is going to be equal to minus 1. If I divide both sides by x squared minus 3, I'm left with minus 1 over x squared minus 3. Okay, so whenever we've got something like this, we never want to have a negative as our numerator. We just want to clean it up a bit. So if we multiply everything by negative 1, remember, if you multiply a fraction by the same value with its numerator and its denominator, it keeps it in the same proportion. So we've just fiddled with it a little bit, but it's the same fraction. Like if you had 3 over 6 and you times it by negative 2, that would be negative 6 over negative 12, but a negative divided by a negative is a positive, so you'd end up with the same value. 3/6 is a half, negative 6 divided by negative 12 is also going to be a half. So therefore, if we multiply the numerator and the denominator by negative 1, we clean it up a little bit. So minus 1 times 1 is 1. And x squared times by negative 1 would be negative x squared, and negative 3 times by 1 would be positive 3. And then we just rearrange it to be 1 over 3 minus x squared. So that one, slightly tricky bit at the end, but remember the little trick, multiply both numerator and denominator by negative 1, and you've cleaned it up. Okay, so for the next part, I am told to, starting with 0.5, use the iteration formula. So that's what I literally just rearranged to find an estimate for the solution of x cubed minus 3x plus 1. So x0 is 0.5, and I'm going to be plugging that into this formula. Remember, all this means is the original term, and all this means is the next term. So iteration is literally the formula that you use to work out the next term using the value of the previous term. So let's start with 0.5. So when you're using an iteration formula and it's a calculator, what you can do, type the first value in. So I'm going to press 0.5 equals, and then I'm going to write the fraction. So it's 1 over 3 take away 0.5 squared. I'm just putting 0.5 in, substitute it into this because xn, that's the original value, so that's going to be 0.5. So I'll write this into my calculator. I press equals, and that, annoyingly, these calculators, please, if someone has any influence, bring back the SD button. It's very frustrating. So 0.36 recurring. So is it recurring or? Either way, it doesn't matter, because what I'm going to do is, now that I've pressed equals, I'm going to go back using my arrow method and delete that, and then press answer, and then press equals. And that will tell me what the next term is. If this is too confusing, just do it bit by bit and substitute each value in. So that would be 0.36 0.34870,317. And now because I've done it 3 times, if I just press equals, it automatically works out the next term for me. So x3 would be 0.3474144,945. x4 would be, let's press equals, okay, 0.34730,625. Press equals again, is 0.3472971. So what you can see, and this is the cool thing about iteration, each time we're going to get closer and closer and closer to the solution. So what you want to do is get to a part where some of your solutions round to the same thing. So after the 3rd term, we can see that all of my values are going to round to 0.347. So in this case, it hasn't told you to use the iteration formula twice. So you just keep going until you find that pattern. So you're going to say x is 0.347, and that is to 3 decimal places. Because to 3 decimal places, for all of these values, it rounds to 0.347. Okay, so here we have got a bounds question with speed, distance and time. So it's helpful to just remember, formula, speed is distance over time. So I know that Justine travelled 321 miles, correct to the nearest 5 miles. Okay, so 321 miles, 5 miles above would be 326, 5 miles below would be 316. So when I'm thinking of the highest possible value and the lowest possible value, it's always halfway. So that would be half of 5, which is 2.5. So 321 plus 2.5 is 323.5 is the maximum value that she could have travelled. And 321 take away 2.5 is 318.5. So that's the minimum distance that she possibly could have travelled. So upper bound of distance is 323.5 miles and lower bound of distance is 318.5 miles. Now, she travelled this in 265 minutes, correct to the nearest minute. So therefore, what are the minutes surrounding that? That's 266 and 264. So halfway between that, where could I put this? Upper bound of time is 265. Oh, wrote that wrong. 265.5 minutes. And the lower bound would be 264.5 minutes. So now I've worked out the upper bound and the lower bound of each of my things, I can look at the rest of the question. The speed limit on the road she travelled was 70 miles per hour. By considering bounds, work out if it's possible that she exceeded the speed limit. So if she exceeded it, then she needs to have been driving at the maximum speed, okay? And how do you get the maximum speed? So to get the, if this doesn't intuitively make sense to you, then just pick 2 random numbers. So let's say 10 and 2, and that would be the max and that would be the minimum. And think to yourself, I know that to work out speed, I need to do distance divided by time. So I need to figure out whether I'm using the upper bound or the lower bound. So let's say I use the upper bound. 10 divided by 2 is 5. 2 divided by 10 is 0.2. So I realised that when I use the upper bound and then the lower bound, I end up with the maximum value. So what I'm going to do is I need to find the upper bound of her distance and divide that by the lower bound of her time, because the more you travel in the less amount of time, the higher your speed must be. So what's her upper bound of distance is 323.5 miles. Now the lower bound of time is 264.5 minutes, but whenever dealing with time, distance and speed, I always want to write that as a fraction of an hour. So what I'm going to do is write 264.5 divided by 60, which is 4.408. And I think that's 3 recurring. I wish it told you whether it's like actually recurring. Let's just say it is. So 4.4083 recurring hours. Okay, so let's do that. So 323.5 divided by answer equals 73.38374,291. Is it possible that she exceeded the speed limit? Yes, it's possible. If she drove the max upper bound distance in the lower bound time, she exceeded it by over 3 miles per hour. Okay, so in this question, I am dealing with functions, and for the first part, I am told to find f of g of 64. So with functions, especially composite functions, we always start from the inside out. So first of all, I'm going to find g of 64. So g of 64 is where x has the value of 64. So the cubed root of 64 plus 3 over 4. The cubed root of 64 is 4, but if you didn't know that, just use your calculator. 4 plus 3 is 7, so that would be 7 over 4. So I'm then going to substitute 7 over 4 into f. So that would be 2 times 7 over 4 plus 4, and 2 times 7 is 14, so 14 over 4 plus 4, that would be 7 over 2 plus 4, which is 3.5, so 7.5. So that would be 7.5. For the next part, I'm being asked to find the inverse of g. So what I do is I'd say y equals the cubed root of x plus 3 over 4. I then switch my x and my y variables. So x is the cubed root of y plus 3 over 4, and I'm rearranging it to make y the subject. So multiply both sides by 4. 4x is the cubed root of y plus 3. Take 3. So 4x take 3 is the cubed root of y. And then what do I have to do? I have to cube both sides. So y is going to be 4x take 3 cubed. And then instead of y, I'm just going to say g minus 1 of x equals 4x take away 3 cubed. Next part, I need to solve. G of f of x is 8. So f of x is this. I'm going to substitute that into g. So that would be the cubed root of 2x plus 4 plus 3 over 4 must equal 8. So now I just rearrange everything to solve it. So multiply both sides by 4. So the cubed root of 2x plus 4 plus 3 must be 32. I can then take 3 from both sides. So the cubed root of 2x plus 4 is equal to 29. Then I can cube both sides. So, might need a calculator for this one. So always have your calculator on hand. 29 cubed is 24,389. If I take 4 from both sides, then 2x is going to equal 24,385, and therefore x is going to be half of that, which is 12,192.5. So in this question, I'm told that there are only blue and yellow fish in a darkened fish tank. There are n blue fish and 7 yellow fish. Amy is going to choose a fish to take home. She says the probability that the fish will be blue is 6 over 10. Show why the probability cannot be 6 over 10. So I know that the probability of getting a blue fish would be n over n plus 7. Now, in order for the probability to be 6 over 10, well, the minimum it could be is 3/5, but because there's 7 yellowfish, I know that 10 would be the minimum. N over n plus 7 must equal 6 over 10. So therefore, if n is 6, n plus 7 must equal 10, which it can't, because n plus 7 would be 13. So the minimum probability it could be is 6 over 13. It would need to be anything that is more than a multiple of 7, but hopefully just showing that is enough. Now, so you'd say that if n was 6, then there would need to be only 4 yellowfish. But let's assume that if there were 7 as a minimum yellowfish, so if that is the case, 7 plus n, the minimum it would be, n could be, would be 1. So it'd be 1 over 8, which similarly cannot simplify to 6 over 10. So no options allow you to simplify to 6 over 10. Next, we're told that after Amy has placed her first fish in the jar to take home, she chooses another fish as she doesn't want it to be lonely, which is very nice. Given that the probability that both the fish she chooses will be blue is 5 over 26, find the total number of blue fish in the tank. So I know that the first option of a blue fish would be n over n plus 7. And then if she chose another blue fish, that would be however many blue fish are minus 1 over however many blue fish there are minus 1 plus 7. So that would simplify to n over n plus 7 times by n minus 1 over n plus 6. And I know that that must equal 5 over 26. Using the AND rule, probability of this and that happening, you multiply the probabilities. So let's get rid of some space over here. And let's see what we can do with this. So I know that n multiplied by n minus 1 over n plus 7 over n plus 6 must equal to 5 over 26. So let's expand the brackets. N squared minus n is equal to n squared plus 13n plus 42. And that must equal 5 over 26. So I could rearrange these equations to get me 26 n squared minus n equals 5 lots of n squared plus 13n plus 42. Let's expand the brackets. So 26n squared minus 26n is 5n squared plus 5 times 13 is 65n, and 5 times 42 would be 210. Let me just double check, because it is 5 times 13 is 65 and 5 times 42 is 210. Okay, so then let's just rearrange it to make it equal to 0, and then I have a quadratic. So 21n squared, I've taken away 5, minus 65, so minus 26 minus 65 gives me minus 91, and minus 210 must equal 0. Now I need to find something that is divisible by all of these just to make my quadratic a little bit nicer. So let's try 3. Would that work? 91 divided by 3? Nope. Let's try 7. 91 divided by 7. Okay, that works. So 21 divided by 7 is 3n squared. 91 divided by 7 is 13. And 210 divided by 7 is 30. Equals 0. So now we've got a quadratic, and it's a calculator paper, so I can use the quadratic formula. So let's get rid of some space here. So using the quadratic formula, my values of a would be 3, b is going to be negative 13, and c is going to be negative 30. So the quadratic formula is minus b plus or minus the square root of b squared minus 4ac over 2a. So substitute my values, that would be positive 13 plus or minus the square root of 13 squared. I'm saying 13 squared because negative times a negative is a positive, minus 4 times 3 times by negative 30 over 6. So that would give me 169 take away 4 times 3 times 30 is negative 360 over 6. So let's simplify that. So 13 plus or minus the square root. So 169 plus 360 is 529 over 6. So let's try with a positive. So 13 plus the square root of 529 divided by 6 is 36. And then with a negative, 13 minus the square root of 529 divided by 6 is minus 5 over 3. Well, let's put this into context. You can't have a negative 5/3 of a fish, so n is going to have to be 6. So find the total number of blue fish in the tank. Well, I've worked out that n is 6, so therefore 6 blue fish in the tank. Okay, so here I've got a vectors question. I'm told that ABCP is a parallelogram, which means that all of its sides are going to be equal. So all vectors that are parallel are also going to be equal. So let's just fill that in. K is the point on AC such that A to K and K to C is 1 to 3. Okay, and L is the point on AB such that AL is a third of AB. Okay, so let's start by working out, okay, we'll find an expression for PK in terms of A and B. So PK would be here. So how can I get from PK? Well, there's a few ways. I could either go along here and then down there, or I could go along here and up here. So in order to find PK, I'm going to need to first work out what AC must be. So how do I get from A to C? Well, I start from here, so I'm going to do 4a, and then I know this vector is 5b, so that would be 4a plus 5b. Now, AK is going to be a quarter of whatever AC is, so that's going to be a quarter 4a plus 5b. So then a quarter times by 4 is a, and then a quarter times by 5 is going to be 5 over 4b. So I know that AK is a plus 5/4 b. So therefore, PK is going to be, we're going down, so it's going to be negative 4a plus whatever AK was, which is a plus 5 over 4b, minus 4a plus a is minus 3a plus 5 over 4b. Next, I need to prove that PKL is a straight line. So how do you prove that something is a straight line? Well, in order to prove that it's a straight line, you need to show that two vectors are parallel. And in order to show that they are parallel, you need to show that they are multiples of one another. And they also need to go through the same point. So let's think about the line PKL. It's over here. What vectors is that made up of? It's made up of PK plus KL. So I know that the vector PK is minus 3a plus 5 over 4b. So if I can find out what the vector KL is and show that it's a multiple, then it's two vectors that are parallel and they go through the same point, which is K. So let's have a think about how I could work out what KL is. So how do I get from K to L? Well, I would do this root plus this root. So the inverse of AK, oh no, I've lost where AK was. Damn it. Okay, let's work it out again. So AK is a quarter of, what did I say? AC was 4a plus 5b. So that would be a plus 5 over 4b. Okay, so KL is going to be the inverse of this because I'm going in the opposite direction. So it's going to be minus a minus 5 over 4b. And then plus whatever AL is. So what is AL? Well, I know that L is on the point AB such that AL is a third of AB. And if AB is 5b, then AL is going to be 5 over 3b. So that's quite a nice one actually. So KL is going to be minus A plus 5 over 4b plus 5 over 3b. So let's simplify that. So you could just do your fractional things here. So 5 quarters plus 5 thirds. In order to add or subtract, they need to be the same denominator. So the lowest common multiple of 4 and 3 is 12. So 4 times 3 makes 12, 5 times 3 is 15, 3 times 4 makes 12, so 5 times 4 is 20. So I'd be left with minus A plus 35 over 4b. Is this correct? K to A would be minus, oh, nope. This is what I did wrong. This should be a minus. So therefore, minus 5 quarters. Okay. So therefore, it would be 20 over 12 minus 15 over 12, which would be 5 over 12. That makes a lot more sense. Plus 5 over 12b. Okay. Okay, so I just rubbed everything out so that there's a little bit more space. So I know that KL is minus A plus 5/12b. I know that PK is minus 3A plus 5 over 4b. So I need to prove that they are multiples of each other. Well, PK is 3 lots of KL. How can you prove that? If KL is minus A plus 5/12b, if you multiplied it by 3, that would become minus 3A, and 5/12 times by 3 gives you 15 over 12, which if you simplified it, divide it by 3, is 5 quarters. Okay, so KL times by 3 would give you this. So therefore, we can say that PK is a multiple of KL. Therefore, they are parallel, and both vectors go through the same point K. Therefore, they are on a straight line. Okay, so for the last question, it's only worth 2 marks because I only had 2 marks left to play with, but we've got a geometric sequence, which means to get from one term to the next term, we're multiplying or dividing by something, and I need to work out the value of the second term. So when I've got a geometric sequence, let's just do a really simple one. So 4, let's say we're timesing by 3, 12, 36. What you can do is you can find the common ratio, so what is being multiplied. So if I said 36 divided by 12, that is 3. So to get from 36 to 12, I'm dividing by 3, and to do the opposite, I'm timesing by 3. So that tells me what the common ratio is. So I can apply that to this as well. So I could do 80 plus 40 root 5 over 30 plus 10 root 5. If I just typed that into my calculator, 80 plus 40 root 5 over 30 plus 10 root 5, that gives me 1 plus root 5. So I know that the common ratio is 1 plus root 5, so I'm multiplying everything by 1 plus root 5 in order to get to the next term. So if I know what the value of the first term is, I'm going to multiply that by 1 plus root 5. So 1 plus root 5 is going to give me 5 plus 5 root 5, and that's the value of the second term. So hopefully that was helpful. Obviously not all of the topics are covered in that, and maybe hopefully over half term I'm going to come up with another predicted paper for the rest of the topics that could potentially come up. If there's any questions, just let me know, but hopefully you found that helpful.